video, we continue our solving for the activities in a Grade 10 Mathematics Learners Material, Unit 1, Module 1, Lesson 1 on Arithmetic Sequences. We are now on Activity 2. In this activity, a general term or nth term will be given to you, and you will be asked to give the next few terms. Activity 2 is entitled Term After Term. You are going to find the first 5 terms of the sequence given the nth term. Number 1, a sub n equals n plus 4. Number 2, a sub n equals 2n minus 1. Number 3, a sub n equals 12 minus 3n. Number 4, a sub n equals 3 to the power of n. And number 5, a sub n equals negative 2 to the power of n. To find the first 5 terms of the first sequence, a sub n equals n plus 4, we are to substitute 1, 2, 3, 4, and 5 to the variable n. To find the first 5 terms of the sequence, a sub n equals n plus 4, we are to substitute 1 to n to find the first term, 2 to the variable n for the second term, 3 to the variable n for the third term, 4 to the variable n for the fourth term, and 5 to the variable n for the fifth term. So using our general term for the nth term, a sub n equals n plus 4, changing n to 1, we have a sub 1 equals 1 plus 4. So a sub 1 equals 5. Next, again using the general term a sub n equals n plus 4, we have a sub 2 equals 2 plus 4. So our a sub 2 is 6. For our third term, we use the general term a sub n equals n plus 4. So a sub 3 equals 3 plus 4. Our a sub 3 is 7. Next, to find our fourth term, we substitute 4 to our variable n. From our general term, a sub n equals n plus 4. Now substituting 4 to n, we have a sub 4 equals 4 plus 4. So our a sub 4 is 8. And lastly, for our fifth term, n equals 5. We have a sub 5 equals 5 plus 4. And so, a sub 5 equals 9. So our first 5 terms of the sequence a sub n equals n plus 4, 5, 6, 7, 8, and 9. This is for item number 1. Let's proceed to number 2. For item number 2, our general rule is a sub n equals 2n minus 1. The same thing with what we did on item number 1, we substitute 1, 2, 3, 4, 5 to our variable n to get our first, second, third, fourth, and fifth terms of this sequence. To solve for first term, using our general rule, we substitute 1 to our n. So we have a sub 1 equals 2 times 1 minus 1. So we have 2 minus 1 equals 1. So our a sub 1 is 1. To solve for our a sub 2, we substitute 2 to our variable n. So we have a sub 2 equals 2 times 2 minus 1. Notice that we have changed our variable n. So for our a sub 2, we have a sub 2 equals 4 minus 1. So a sub 2 is 3. For our a sub 3 or our third term, we substitute 3 to our variable n. So we have a sub 3 equals 2 times 3 minus 1. Again, notice that we have changed our variable n from our general rule a sub n equals 2n minus 1. So our a sub 3 is 6 minus 1. A sub 3 is 5. Our third term is 5. The same thing with fourth term. We substitute 4 to our variable n. So we have a sub 4 equals 2 times 4 minus 1. A sub 4 is 8 minus 1. So a sub 4 is 7. So for our fifth term, we substitute 5 to n. So we have a sub 5 equals 2 times 5 minus 1. So a sub 5 is 10 minus 1. A sub 5 is 9. So from our solution, our sequence is 1, 3, 5, 7, and 9 from our a sub n equals 2n minus 1. For item number 3, we use a sub n equals 12 minus 3 times n. So again, we substitute 1 to our variable n to solve for the first term. A sub n equals 12 minus 3 times n. So we change our variable n to 1 to solve for our first term. This becomes a sub 1 equals 12 minus 3 times 1. So we have a sub 1 equals 12 minus 3. A sub 1 equals 9 because 12 minus 3 is 9. For our second term, n equals 2. Again, a sub 2 equals 12 minus 3 times 2. Our 2 here is from our variable n, or changing n to 2. So we have a sub 2 equals 12 minus 6. 6 here came from multiplying 2 and 3. So a sub 2 is 6 because 12 minus 6 is 6. So our second term is 6. Same thing for the third term. A sub 3 is equal to 12 minus 3 times 3. So a sub 3 is 12 minus 9. A sub 3 equals 3. Our third term is 3. For our fourth term, substitute 4 to our variable n. So this becomes a sub 4 equals 12 minus 3 times 4. So our a sub 4 is 12 minus 12. Therefore, our fourth term is 0. For our fifth term, we have to substitute 5 to our variable n. So we have a sub 5 equals 12 minus 3 times 5. Our a sub 5 is 12 minus 15. Subtracting integers, our result is negative 3. So our fifth term is negative 3. So from our general term, a sub n equals 12 minus 3n, our sequence or our first 5 terms is 9, 6, 3, 0, and negative 3. For our item number 4, our general term is a sub n equals 3 to the power of n. Same thing with what we did for the first 3 items of this activity. We substitute 1 to get our first term, substitute 2 to get our second term, substitute 3 for our third term, substitute 4 to get fourth term, and 5 to get the fifth term to the variable n. So n equals 1 for our first term. A sub n equals 3 to the power of n. Changing our n to 1, we have a sub 1 equals 3 to the power of 1. A sub 1 is just 3 as our first term. N equals 2 to get our second term. Using our general rule, a sub n equals 3 to the power of n, we have a sub 2 equals 3 to the power of 2. That means a sub 2 is just 3 times 3 from 3 squared, or multiplying 3 twice by itself. So our second term is 9. To get our third term, we substitute 3. So a sub 3 is equal to 3 to the power of 3, and that is equivalent to multiplying 3 thrice by itself. So 3 times 3 is 27. Third term is 27. For our fourth term, we substitute 4 to the variable n. We have a sub 4 equals 3 to the power of 4. So that just means multiplying 3 4 times by itself. This just means a sub 4 is equal to 9 times 9, or a sub 4 is just 81. Our fourth term is 81. Lastly, n is equal to 5 to get our fifth term. So a sub 5 equals 3 to the power of 5. We have a sub 5 equals 3 times 3 times 3 times 3 times 3, or multiplying 3 5 times by itself. We have a sub 5 equals 9 times 9 times 3. So a sub 5 is equal to 81 times 3, 243. So our fifth term is 243. From our general rule, a sub n equals 3 to the power of n, substituting 1, 2, 3, 4, 5 to get our first, second, third, fourth, and fifth terms to our variable n from the general rule, we can obtain the sequence 3, 9, 27, 81, and 243, the first 5 terms of the given sequence. For last item, Item number 5. Our general rule is a sub n equals -2 quantity to the power of n. This means that in a sub n equals -2 quantity to the power of n, our exponent n applies to both the negative sign and the number 2. So that means if we substitute 1 to get our first term, we have a sub 1 equals -2 to the power of 1. A sub 1 is just -2 itself. That is our first term. For our second term, we substitute 2 to the variable n. We have a sub 2 equals -2 to the power of 2. Notice here that our n becomes 2. So we have a sub 2 is equal to -2 times -2. This will give you positive 4. Negative times negative is positive. 2 times 2 is 4. 4 is our second term. For our third term, a sub 3 equals -2 to the power of 3. So a sub 3 is just -2 times -2 times -2. A sub 3 is just positive 4 times -2. Applying the rules of multiplying integers, we have -8 because positive multiplied to negative will give us a result of negative number, and multiplying the numerical coefficients 4 and 2, we have 8. So our third term is -8. For our fourth term, substituting 4 to our variable n, we have a sub 4 equals -2 to the power of 4. A sub 4 is just -2 times -2 times -2 times -2. We multiply -2 by itself 4 times. So we have a sub 4 equals positive 4 times positive 4. And you have here positive 16 or just 16. Applying the rules of multiplying integers, positive times positive is positive, and 4 times 4 is 16. So our fourth term in the sequence is positive 16. To get our fifth term, we substitute 5 to variable n. We have a sub 5 equals -2 to the power of 5. So this means a sub 5 is just -2 times -2 times -2 times -2 and times -2. Multiplying -2 by itself 5 times. So we have a sub 5 equals positive 4 times positive 4 times -2. A sub 5 is just positive 16 times -2. Applying the rules and multiplying integers, we have positive times negative is negative. 16 times 2 is 32. So a sub 5 is just -32. Or our fifth term is -32. If our nth term or our general rule is a sub n equals -2 quantity to the power of n, our first 5 terms are -2, positive 4, -8, positive 16, and -32. How did you find the activity? Did you find it easy to give the first 5 terms of the sequence? In the next activity, you will be given the terms of a sequence and you will be asked to find its nth term.